Okay, this is a really tricky example, and we're going to look for, well, not tricky, just tedious. So we're going to look for a shortcut. Okay, so we're going to have to do integration by parts 3 times. So, are you ready? So I'm just, instead of drawing the box, I'm just going to draw a grid. So I have u, v, du, dv. So LIATE, logs inverse algebra. So x cubed e to the 2x dx. So we're going to be careful of that 2x because that's going to mean I have a linear inside and I'm going to need to undo that. So this gives me, when I take the derivative, 3x squared dx, and then e to the 2x over 2. Okay, so this equals 1/2 e to the 2x x cubed minus 3 over 2 e to the 2x x squared dx. Okay, so a nice idea here is to pull the constant out front, and then you don't have to worry about it in the question. It doesn't matter, you can leave it in the question or not. I'm not going to carry it through the integration by parts piece because it'll be easier not to. So now I have the x squared, which gives me 2x dx, and I have e to the 2x, which gives me e to the 2x over 2. Okay, so I'm just going to be careful here. So minus 3 over 2 times all of this. So x squared e to the 2x over 2 minus 2x over 2 e to the 2x dx. And then I'm going to clean this all up before I integrate again. So I have minus 3 to the 4 x squared e to the 2x, and then plus, that cancels, this minus and this minus give me a plus, and I get 3 over 2, and then x e to the 2x dx. Okay, so I still have to go one more time. I still have a product. And I get u, v, du, dv. So x dx e to the 2x e to the 2x over 2. Okay, so here we go. So you could tell that you're going to need to do this 3 times because of the e to the 2x is going to keep cycling, but the x cubed eventually will take 3 times to get down to a constant, right? So e to the 2x plus 3/2, and then I'm just going to be careful to put this all in brackets, and I get x e to the 2x over 2 minus e to the 2x over 2 dx. Okay, and I'm almost done. So 3 over 4 x e to the 2x minus 3 over 4 e to the 2x dx. One more go. And then this is 3 over, and this is e to the 2x over 2, so this will be over 8, and then plus c. Whew! All right. So it turns out that, you know, if you look at what's happening here 3 times, you can see that I start with x cubed, and I just keep taking its derivative, right, until I get down to 1. Now, I mean, I'm off by a constant because I kept pulling the constant out. And then you can see that we start here and we just keep finding the integral. So we're going to see if we can do this question a little quicker. Okay, so we're going to try something called the tabular method. Now you want to be careful. You want to do this when you have a u that is algebra and is going to go down to a constant. So let's do the same question. Okay, and I'll do the method over here. All right, so we have a u. So we just start with the u and the dv, which is the two parts of the question. And you want to do this when your u is algebra, because that's the only one that's going to go down to something that disappears. Okay, so then you start with your u, and you start with your dv. Okay. And then you're just going to take the derivative until you get to a constant. Okay, and so once you're at a constant, you're done. And then you're going to alternate the signs. And you're doing this because every second time you take the integral, you are subtracting it, right? And then adding it. So you can see that the sign is going to switch all the way down. And then on the other side, so this side you were taking the derivative. And then over here you're going to integrate. So you get e to the 2x over 2, so I'll make that 1/2. And then e to the 2x over 1/4. So I'm integrating this. And then e to the 2x over 1/8. And then you're going to go one more time, e to the 2x over 1/16. So you want to go one more than the other side. Okay, and then you're going to take the plus this times this, minus this times this, plus this times this, and then minus this times this. And then that should be your answer. So let's see if that's true. So I get 1/2 x cubed e to the 2x minus 3/4 x squared e to the 2x plus 6 over 8 x e to the 2x minus 6 over 16 e to the 2x, and then at the end I just put plus c. And then if I clean this up, what's that, 3 over 4, and then what's this, 3 over 8. Okay, and then I can just look up and I should get the same answer. So that's a lot easier. So when do you use the tabular method? When your u is the algebra. And you can see if that algebra, the power on the algebra is how many times it's going to take. So, you know, if it's just x, then you might as well just do regular integration by parts. There's no need to do a tabular method. But if it's x squared, x cubed, x to the 4th, then you're going to be using a table. And then you just alternate your signs, and this is because there's a minus inside the formula. And then you just pair them up with one down from, because you don't actually use that part in your question, right? You use the integral of it. Okay, so let's just try one more example to make sure we get that. Okay, so example. So x to the fourth sine x dx. So this is a good tabular method. I'm just going to leave a space so we can answer the question here, and then we'll put the tabular method below. So my u is x to the fourth, and my dv is sine x. So I'm going to make this plus, minus, plus, minus, plus. Okay, and once I'm at a constant, I can stop. Okay, I'm integrating. So the integral of sine x, you want to be careful, is minus cos x, and then minus sine x, and then cos x, and then sine x, and you want to go one more, so minus cos x. And then your answer is going to be this times this times this. So you can convince yourself why this is true, maybe by looking at my first example. So then the answer is minus x to the fourth cos x plus 4x cubed sine x plus 12x squared cos x minus 24x sine x minus 24 cos x plus c. So this would have taken 4 integration by parts. Okay, so hopefully that was